This part here, this is PDF. Okay, probability density function. So your calculator will always have a when it's equal sign. This is PDF. So this is px equals to x. Okay, cumulative CDF will be always equals to that's why we and always start counting from 0. See, starts from 0. Okay, so just remember that. So CDF, PDF, C stands for cumulative. So very quickly, if you want to find px equals to 10, what you do is you just put in quit first. Just this distribution, second distribution, scroll up to binomial PDF, press enter. Trial should be 25. And then each successive trial is 35%. Okay, and you want it to be 10. X value is 10. There you go. This is what you key in. This is what you key in. Huh? This one is okay. This part will be 0.141. Okay. Any question? Now, what is... It should be quite okay. This one should be quite okay. PDF, this is PDF. PDF is in this one. Now, what is not okay for students typically is part 2 onwards, changing it, which you need to practice. Okay, so this case here, what we want is actually px more than 12. Remember this, you need to change to, no matter what, change this to less than or equal to, because your calculator only have less than equals to. So this case here, this is CDF. So but what you need to do is actually take 1 minus, now this is where most of the students have problem, less than equals to either 12, okay, this is the usual careless mistake here, wrong, this is very, very important, okay, this is very, very important, it's wrong, okay, because what happens here is we do not want the class of 12. This is 13, right? I don't know where is it. And so on, this class, you do not want the class of 12. You want, what you want is actually more than 12. So 13 onwards. So this whole class here, you do not want. Like the 0 to 12 here, you do not want. You want to omit it. Okay? So this is where most students, some students have problem with. This one, make sure you know how to change. Okay? Okay, so but give you another example. You need to know. So for example, if px bigger equals to 12, then this will be 1 minus px less than equals to 12. Is 1 minus px less than equals to 11. Okay, because you want the class of 12, you don't minus off the class of 12, you put 11. Okay, so this case here, remember, put in binomial distribution CDF instead. X value here will be 25, 30, 25, and 0.35. Okay, then this will be 12. This case here. Okay, so this case here will be this 1 minus this answer here. 0.06044. 0.06044. Okay, please do the subsequent one. Then we need to do this one here is 1 minus px less than equals to 14. Okay, you do not want a class of 14, that's why is then this is okay. This one just key in our PDF. Okay, now the third one I need to explain a bit. X is discrete. This is discrete. Okay, this is important. Meaning you cannot have this one here. Now, when it's normal distribution, if it's continuous, then you can just key in. But this is discrete, meaning you need to count to a discrete level. Then you just do this. 8, 7, 8, 9, 10, 11, 12, 13, 14, 15. What am I doing? Okay. Now, 8 point. So I'll just explain this. 8.12 is here. Then you 14.36 is here. Okay. What you want is essentially a discrete value, so you need these classes in between. So in other words, what you need is P9 equals to X less than 14. Please understand the concept behind changing it to a discrete value there. Okay. What you want is the classes here, the classes in between here. So once you do that already, this will be actually using CDF would be Px less than equals to 14 minus of Px less than equals to 8. Okay? Px less than equals to 14 minus of Px less than equals to 8. Is that okay? You do want the 8, so you minus off the 8. So this is what you do, lor. You just key in calculator, binomial CDF, 14 minus binomial CDF. CDF, 8 CDF cumulative. So this will be 0.5238. 0.5238. Is it okay? Px equals to 17, at least 17.3. Same thing, this one here. If you're not too sure, what you do is you can just draw the diagram out, the number line. This is like sequence and series because they are discrete, so it's quite straightforward in the sense. 17.3 is here. Okay, you want all the classes 19. So you can is as good as writing 18 onwards. Okay, equals to 18 onwards. So then this will be 1 minus px less than equals to 17. Must be able to write this down proficiently. Really cannot do not know what to do. So this 1 minus of CDF that will be 17. Oh, very small. 1.8077 times 10 to the power minus 4. Okay. So this one will be 19. Okay, key in calculator. Then part 5. Part 5 is 9. Okay, so this is what you do is I think this is easier. Minus 9 between, okay, first of all, change this to equal sign first. Change it, I think the easiest is to change this to equal sign first because this is 8, right? Change to lesser equals to. So if you want it to be less than 9, it has to be mod x minus 10 less than equals to what? 8. Okay. Then you just do the same thing, which is this is just doing this. Okay. Then add 10 both sides will be 2. Okay. Then you just do there you go. Change this to equal sign first. Then you just do that. Binomial CDF 18 minus all binomial CDF 1 0.99966. Okay, usually when if we round to 3SF is 1, we just leave it as 4 dp or 5 dp. We don't change to 1. Okay, so usually that's the case. Subsequent one, same thing. This one here, 1 minus p x minus 12. You do not want the class of 3 because you do not want 3 here. So less equals to 3. Remember that? Then p 9 you need help with any of it, let me know, okay? Now, every distribution that we learn is going to have mean and going to have standard variance, which means it's standard deviation. So just take note, the variance and standard deviation is also given MF26. The mean is n times p, and the variance is np 1 minus p, okay? So if you were to list down all, like it's actually a discrete random variable. So if you were to draw the whole thing out, 0, 1 to all, then you multiply them, you definitely get the expectation NP. Okay, but I'm not going to do that here because it's quite pointless. So if EX is with n times P, n is 25. 25 times 0.35. Variance of X will be 25 times 35 times 1 minus 0.35. Okay, so just key in. So this will be key in here. This will be 8.75. This will be variance is 16 square sigma square. So sigma will be square root of 91 over 16. Now, probability of X lies within one standard deviation away from standard deviation. One standard deviation away from the mean. The mean is sigma. One standard deviation will be, the mean is mu, which is X. Standard deviation is actually sigma. Okay. What does it mean? It means that the probability of X, if this is X here, we want it to be one standard deviation away. So this is mu plus sigma, and this is mu minus sigma. Okay. This is what it meant by one standard deviation away. So the probability that you're looking for is actually P mu minus sigma less than X mu plus sigma. Okay. This is one standard deviation away from mean. Means you take a mean, you plus a one standard deviation. You take another mean, you minus a one standard deviation. That will be the standard deviation that we're looking at. Then once done, this will be probability of, you just key in calculator is x. This will be p x less than equals 11 minus of p x less than equals to 6. Okay, there you go. One standard deviation from mean, we will use quite often. Sometimes we'll use it in normal distribution. You can also write this as px minus mu is less than sigma. This is one standard deviation away from the mean. Okay. You can write this both. It's the same thing lah. It means the same. Because in normal distribution, we know that from the mean, one standard deviation away is about 66.66%. Okay. That's about it. I think 66.6%, yeah. 66.7%. Okay, the mode means what? Mode of x means what? Mode means most frequent. Okay, most frequent class that you want to find. Now, in other words, if you think about it, right, what you want to find is, if let's say 0, this is 1, and so on, you want to find the one which has the higher probability. It ends with what? This one ends with. It definitely will peak and go down because of the Pascal triangle. This is until 25. Okay, you want to find this is the most frequent one. So this is like X here lah, or A here. The mode will be A lah. Probability will be the most frequent one. In other words, I need to go down to each. I need to calculate each and every one of the probability. Okay? Use your calculator. Use your calculator to, this is important. This is where you do it. Distribution. Go to Binomial PDF. Binomial PDF. Follow me very carefully. Binomial PDF. Trials. You put 25. This one put 30%, 35%. X value here, you put X. What you're doing here is you go and calculate each classes, which class gives you the highest probability. So here, of course, now if say your table starts like that, let's say it's like you have this gibberish here, you do not know what's going on, right? If this is the gibberish that you see, go to table set, press 1 and 1, just change, or just zoom standard lah. You get this graph here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now this is your answer here. This tells you the probability of each individual class. So let me just label this down for you. Okay. Okay, let me write down for you what you can key now. This is what you key. This one is important because when the question comes up, a lot of students don't know how to find it. Okay, this is it. So this part here, this is when x is 0, x is 1. So this is actually px equals to 0. Px equals to 1 is this value here. This is px equals to 2 and so on. Do you see that the highest probability, the most frequent one is px equals to 9. This is the most frequent one. Okay, highest probability. So hence, mode of x is 9.